Hi everybody, Dr. Ide here, and I just wanted to go through elasticity and elasticity of demand for you, since you have your discussion on it, you have some homework on it, you have some case studies on it, and I felt that you really needed an example and a walkthrough in order to be able to do that. I know that I said we were going to save it for next class, but I kind of wanted to do this video and get you guys going a little bit sooner. So we are going to talk about Chapter 8, Elasticity, and we are going to be going over exercise 8.5. This is in your textbook on page 132. So what I want you to do is go ahead and turn to that right now and follow along with me, and we're going to go through elasticity of demand right now. I'm going to share my screen with you guys, and we are going to get moving. Let's see. I know it's one of these. It would be... I have two screens going, so I just have to pick the right one. There we go. And now I chose the right one. All right, everybody. So here's what we're going to be doing. We are going to be looking at elasticity and income elasticity of demand. And that was a mouthful for me today for some reason. I don't know why. Okay, so let's take a peek at what we're doing here. So again, we are talking about Chapter 8, elasticity and income elasticity of demand. So before we can chat about income elasticity, we have to talk about what elasticity is in general, okay? So elasticity is, and I want you to remember kind of like, you know, a rubber band, right? You can manipulate and change a rubber band because it's elastic, right? It can be, it's flexible. It can be moved from one point to another. You know, you could change it. It changes. You can change it. So elasticity, like a rubber band, can also be changed. So what it is it's an economic measure of how sensitive something is to something else. So for example, changes in price to supply or demand, right? So basically, if the demand is high for something, you could charge more for it. If you don't have a demand for it, you know, you could try to charge a lot for it, but you know, who's going to buy it? And supply. If you have a large supply of something, that is going to be something that's totally different from you not having, you know, enough of something, a supply of something. Look at the PPE from the COVID pandemic, right? Okay, so it could be changes in price to supply or demand, or changes in demand to changes in income. And all that means is, you know, sometimes we can afford things, sometimes we can't. It's all based upon, you know, can we afford it? How much are we making, right? So these are very, very simple, easy concepts for you guys. And these are things that you have gone over and that you know already. So what I want you to think about when you're thinking about elasticity is just think about changes in supply, demand, or price, right? So examples of elastic goods include clothing or electronics, and inelastic goods are items like food and prescription drugs, right? So if demand for a good or service is relatively static, even when the price changes, demand is said to be inelastic, and its coefficient is less than 1. And if that means nothing to you, if that was a whole bunch of hoopla right now, then that's fine. Because as we talk about this, and as we go through the example, this will all become very clear to you what this actually means. But in case the word static is throwing you off, static means you're not changing. Nothing's changing. You're lacking change. You're lacking action. Everything's pretty much the same. Okay. So don't get confused when you see words like that and you're thinking, well, I don't know what the heck that means, right? So, you know, again, if something is static, it's just lacking, you know, change. It shows very little to no change at all. So if a good or demand is relatively static, meaning that it's not changing in any kind of way, even when the price changes, the demand doesn't change. The price could change, but the demand's not changing. It's pretty much remaining the same. Then that demand is said to be inelastic because it's not changing. So when something is inelastic, it's not changing. It's just kind of staying the same, okay? And when that happens, the elasticity coefficient, really fancy terms here, right, is less than 1. So if you have a number less than 1, it's inelastic, and that's going to matter later on. So how does elasticity work? So when the value of elasticity is greater than 1, it suggests that the demand for that good or service is affected by the price, right? So it's elastic if it's more than 1, because the demand is affected by the price. So if the price goes up, maybe there's a lot less demand for it. That would make it elastic because it is changing. Inelastic means it wouldn't change. So less than 0.1, or I'm sorry, less than 1.0, it's inelastic because the demand doesn't really change no matter what the price. But it's elastic if the value is 1 or greater. So that just means that the demand for the good or service is affected by that price. Okay? All right, so a value that is less than 1 suggests that the demand is insensitive to the price or inelastic, meaning it doesn't change. Inelastic, again, means that when the price goes up, consumers' buying habits stay about the same. And when the price goes down, they remain unchanged, hence the term unelastic. Nothing changes. So it doesn't matter if the price goes up or if the price goes down, people still buy it. So they say there's no real world example for this. So the only thing close to something that's perfectly inelastic would be air, water. No one controls those things. So it doesn't matter if prices go up or down in the world, you still need to breathe, right? So you're going to take in the same amount of air no matter what the price of anything is. All right, so that's kind of like a funny example, but that's really truly the only thing that could be inelastic because pretty much everything is affected by price. Insulin, though, is a product that is highly inelastic. All right, it's not perfectly inelastic, but it's highly inelastic. What does that mean? It means that for people who need insulin because they have diabetes and they would die without it, the demand is so great that, even when prices increase dramatically or drastically, that has very little effect on the quantity that's demanded because people need it to live. So it's highly inelastic. No matter the price, the demand stays the same. If you were going to die without something, you would find a way to pay for it, right? So price decreases also do not affect the quantity demanded because it's not like you're like, woohoo, let me take 12 times the amount I'm supposed to of my insulin today because the price is dropped, right? You wouldn't take more. That would be insane. You have to take your prescription or your prescribed amount. So even if the price goes down, it doesn't matter. You're going to want and need the same amount. Does that make sense to everybody? So, if you need insulin because you have diabetes, even if the price goes up, you're going to need the same amount. And even if the price goes down, you're going to have and take the same amount because that's the amount you're supposed to take. On the other side of the equation are highly elastic products. So they give the example of bouncy balls online all the time. So bouncy balls, they're highly elastic. You don't need a bouncy ball, right? But you say you take your kiddo to Walmart and they say, Mom, please, 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 or Dad, please, 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 give me this bouncy ball, give me this bouncy ball. And you're being driven insane. And the great question is, how much is it? And the kid's like, it's only $1 or whatever the case may be. And you're like, okay, it's cheap. Just get it. And don't ask me for anything else, right? So bouncy balls, for example, are highly elastic. And then they're not necessarily something that you need. They're not something that the kid needs. They'll die without a bouncy ball. But you will decide to make a purchase if it's cheap, right? If the price is low. So therefore, if the price of bouncy balls increases, the quantity demanded will greatly decrease. And if the price decreases, the quantity demanded will increase. Therefore, it's elastic. It goes up or down. The demand goes up or down depending upon if it's cheap or if it's expensive. No one's going to buy their kid a $100 bouncy ball, right? That would be ridiculous. But if it's $1, everyone's like, okay, in order to get this kid to kind of be quiet, let's get them a bouncy ball. All right, so let's consider the following. Income elasticity of demand is an economic measure of how responsive the quantity demand for a good or service is to change in income. Same thing. Is it elastic or is it inelastic? If it's inelastic, the demand is not going to change very much, even if income changes. If it's elastic, the demand is going to change based on that change in income. Same thing. So the formula for calculating income elasticity of demand is the percent change in quantity, the percent change in quantity, there's that quantity again, the quantity demanded, divided by the percent change in income. So the percent change in quantity demanded, and of course I'm smart about it, a smart aleck, and I want it now, right? That's the percent change in the quantity demanded over the percent change in income. So businesses use this measure to help predict the impact of a business cycle on sales. Okay, so if people, if the economy takes a dive and people lose their job and there's a large percent change in income, right? That could mean disaster for a business, because it would become elastic. There would be a large percent change in the quantity demanded, particularly if it's not something that people need to survive, right? You lose your job. Consider this, you lose your job, right? And maybe something that you enjoy having is cable television. But these days, you really don't need cable television. You have smartphones and smart TVs and apps and all sorts of content that you can get for free. So you really don't necessarily need cable TV to even see programs anymore. You can go on YouTube, there's apps, whatever. So if you were Verizon, or if you were Cox, or if you were some kind of whatever cable company you have in your area, you would be closely watching the economy. You would be closely watching percent change in income of folks in the area, because if that percent change of income, if they start making less money or they lose their jobs and they're not making any money anymore, then you're going to see an elastic, you're going to see that income elasticity of demand. You're going to see that percent change in the quantity demanded, right? Okay, so think about it, very practically. So here is your question. We needed to review that in order to get to where we are. On page 132, I believe it was, although I didn't put that on this slide, which would have been helpful, but you should already be there. In exercise 8.5, it says per capita income in the county was $40,000. Okay, the physician visits averaged 4 per person per year. So people made about 40 grand, and they went to the doctor about 4 times a year. Per capita income, rose to 42,000 a year. And physician visits rose then to 4.02 per person per year. So you're already going to say, well, that doesn't sound like a whole bunch, right? But let's see. So the question is, what is the percentage change in visits? What is the percentage change in income? And what is the income elasticity demand for visits? All I did on this slide was I documented the differences between last year and this year, per year. So last year, the per capita income was 40 grand, and there was 4 visits per person per year. That's what my PP means, per person. This year, people are now making about 42,000, and there's 4.02 visits per person per year. So now we have all of our data. Now we just need to tackle the questions. The first question, what is the percentage change in visits? What is the percentage change in visits? Okay. So in order to figure out what the percentage change in visits was, we need to first figure out, or do our equation, So what was the percent change in quantity? What was the percent change in quantity? So in quantity, so that means how many visits, right? We were going 4 times per person per year. Now we're going 4.02. So all we have to do is do the percent change in quantity. How do you do percent change in quantity? You take the current year's quantity and you subtract last year's quantity. That's it. And let me put that on here. I always think I'm being super specific, and then I realize I wasn't. I always think I'm being more specific than I was. That drives me insane. Okay, so let's do this. So in order to get the percent change in quantity, the percent change in quantity, not quality, quantity, that equals current year's quantity, which is your Q, or your visits, right, minus last year's quantity. Okay, and the Q in this case would be your visits. So let me put that. Okay, all right, visits. So you had 4 visits per person per year last year, and you have 4.02 this year. Okay, so your percent change in quantity equals current year's visits minus last year's visits. So it's 4.02 minus 4. Then you just divide that by the percent change in income. Okay. So, actually, let me take this away for now. Percent change in quantity divided by, because I did something where I moved ahead too quickly. So percent change in quantity, and we're going to divide that by your last year's quantity. Okay. So your percent change in quantity over last year's quantity. So how do you get percent change in quantity? Again, your current year's visits minus your last year's visits. So you do 4.02 minus 4. And then you divide that by your last year's quantity, which is 4.0. So when you do, and I'm going to grab my calculator here. When you do 4.02 minus 4.00, that comes out to 0.02. So that's how we got that number. And then you just divide that by last year's quantity, which is 4.00, and that equals 0.005, right? But it's asking us what's the percentage change in visits, okay? So in order to get the percentage change in visits, you would have to take this decimal and change it to a percentage. How do you do that? You simply see this decimal, you move it 2 to the right, 2 to the right. That's how you turn a decimal into a percent. Decimal 2%, move decimal 2 spaces to the right. Okay. And once you do that, so 1, 2, it would be 0.5% or 0.5%. Okay. So what is the percentage change in visits? 0.5% is your answer there. 0.5%. Okay. Next, and I'm going to make this bigger now. Okay. The next question, what is the percentage change in income? All right, because they're asking 3 totally separate questions. So what is the percentage change in income? The first thing we do to get the percentage change in income is we subtract the most current period's revenue, which was $42,000. Remember, it rose from last year's, which was $40,000. So, and let's go back so I can show you this. Our per capita income last year was $40,000, and this year it's $42,000. See that? So you just take the $42,000, which is the current revenue, and you subtract last year's revenue, and then you get $2,000. So there was a $2,000 difference between last year and this year. So once you do that, you divide the result, which was this $2,000, by the revenue number from the earlier period and multiply by 100. So what does that mean? That means you do the change in income, which was the $2,000, and we got the change in income again just by subtracting this year's revenue from last year's revenue. So that's $2,000. We divide that by last year's revenue, which was $40,000, and we times it all by 100. So let me pull up my calculator again, and I'm going to have to make this small. Whoops, I keep doing that. Oh, I did it again. Okay. So how do we do this again? And I'm just doing this so you could follow along with me. And so you make sure you know what you're doing and you know, you're seeing what I'm doing. So you would do 2,000 divided by 40,000, 1, 2, right? And that would equal 0.05. But then of course you have to times it right here. You have to times it by 100, and that equals 5%. Remember, please excuse my dear Aunt Sally. Okay. So, you got 0.05 times 100, that's 5%. So what is the percentage change in income? the percentage change in income. So you have 5%. There was a 5% change in income. Okay. What is the income elasticity of demand for visits? So you have to ask yourself, how do I get the income elasticity of demand, right? So the income elasticity of demand is the percent change in visits divided by the percent change in income. And you're going to notice that you did these two things first. So you're just taking the two previous answers and you're dividing them. And percent change in visits, let's go back there. What was the percent change in visits? It was 0.5. What was the percent change in income? It was 5%. So you're just taking that 0.05 and you're dividing it by 5, and that equals your 0.10. And as we learned, anything below 1.0 is going to be inelastic. It's going to be inelastic, right? Anything below 1.0, it's going to be inelastic, which means we didn't really see the demand change very much based upon, the percentage change in income. Okay? Okay. Perfect. Perfect. And I'm not sure if I think I may have put this incorrectly. I don't think that was 0.05, was it? Let's double check this. Oops. I don't think it was. Let's double check. In the meantime, and again, when I'm breaking all this stuff down, I make this PowerPoint really quickly for you guys before I come back. So then sometimes I just have to change it. But the percent change in visits, the percent change in visits was 0.5. Yeah, so it was 0.5 divided by 5. That will drive me crazy. It was 0.5. I accidentally put an extra 0 in there. It's 0.5 divided by 5. And I'm just going to show you this. I'm looking at it and I'm thinking that wasn't right. So it was 0.5 divided by 5. It is 0.10, right? And anything below 1.0 is inelastic. And sometimes you'll make, when you're working with numbers, sometimes the same thing happens. You're going to transcribe something incorrectly, but that's why I always pull up my calculator and I do everything on my calculator. Because what happens if I took this number incorrectly? I was looking up here and for some reason I put a 0.05 instead of 0.5. That would have messed up my whole calculation. Luckily, I've done this so many times that I know what the answer is. But if you're doing this too quickly, make sure you're double checking your numbers. It's another reason, that's another great example of why you need to write everything down and write out each one of these steps. If you don't write out each one of your steps, you're going to get confused, you're going to get lost, and you do not want that to happen. So be sure that you're writing down each one of these steps. You know what you're doing. You're not missing anything, and you're checking your math a couple different times. Okay. So that concludes our discussion on 8.5. I hope that I did that concisely enough so you guys were able to follow it. And I hope that, we all learned a lesson from that last slide there. To make sure that when we're moving our numbers over, that we're putting them correctly, because decimal points are like that. It could be 0.05 or 0.5. There's a big difference between 0.05 and 0.5, right? And you don't want to mess that up. All right, I'm going to leave you with a challenge on this. Try 8.8 on your own and send it to me, and I'll let you know if you're correct. You could do this, you could not do this. It's up to you. I would like to see you do it because I want to see, I want to see you guys challenge yourselves. All you would have to do is come back to this PowerPoint and really just follow the steps that I did, because it's the same type of question. All right, I'm going to stop sharing now. And I'm going to tell you guys, I'm going to put on my camera again. And I'm just going to go ahead and say goodbye for the day. What I want you to do is make sure that you read this chapter over very carefully and use some of this stuff. What I told you now can be completely used in your discussion. So be sure you're reading. If you didn't understand it to begin with, after going through this video, hopefully you did. Let me know if you need anything else. And thanks a bunch, guys. Have a great weekend. I really appreciate, all you're doing, particularly during COVID, to, stay in classes and to keep up with everything. It's really awesome. Thanks. Have a wonderful day, guys. Bye-bye.